Happy Friday. So we're going to do something that's very similar to something we did before. Actually, it's putting two things that we've done before together into one thing. So previously we've studied systems of linear equations. We solved the systems by graphing to find their point of intersection. We also learned that we could solve the system algebraically using the elimination or substitution methods to find the point of intersection of the two lines. The image below illustrates a system involving one line and one curve, particularly a parabola. So that's what we're going to be looking at today. We're going to solve the system by graphing, and then over the next several days we'll do elimination and substitution. So remember that the solution is the point of intersection, and before we were just talking about two lines. So there was only one point where they crossed, so there was only one solution. But now we're going to be dealing with a parabola and a line, or maybe even a parabola and a parabola. So we're going to have potentially more than one solution. So consider other possible systems involving one line and one parabola. So make a series of sketches to illustrate the different ways that a line and a parabola can intersect. In other words, explore the possible number of solutions to a system of linear quadratic equations. That sounds scary. I'm only gonna show you one here. I want you to come up with different ways, aside from what we have in the picture above, that we could have a parabola and a line. So for example, I'm just gonna draw a random parabola. Just kinda wanted to make the vertex so that it would be symmetric. And then I could have a line like this, and this would only have one solution. So the one above has two solutions because there were 2 points of intersection, right? 1, 2. This one only has one solution. So I want you to come up with two other ways to draw a system that involves a parabola and a line, and see if you can get different looking graphs. So that's part of your homework. Consider other possible systems involving two parabolas. Two parabolas. Okay, so let me give you one example of what two parabolas could look like. I'll give you the one that's like probably the least obvious. I could have a really skinny parabola, and I could have another one directly below it that is really wide. So here's my question. How many solutions does that parabola have? Remember, the solutions are the places that the line and curve, or line and line, or curve and curve cross each other. Are these ever going to cross? No. No solution. So I want you to think of two more ways that you could draw two parabolas. They do not, hint, they do not have to open in the same direction. And I want you to see, I don't want it to be no solution. I want these other two to actually have places where they cross. One or two places where they cross. So that's another part of your homework. All right. So a solution, what it means for something to be a solution is that the point when you plug it in, if I plug in a 4 for y and a 2 for x, I get a true statement. 4 does equal 2 plus 2, but it also has to work for this one. Plug a 4 in for y and a 2 for x, and that also works. 4 is equal to 2 squared. So if it works for just one of the equations, then the point is not a solution. Okay, let's skip down here. You guys can read through the rest of that after you go back to the first page. Okay, so solve. These are what you're going to be doing. Solve by graphing and then verify your solution. So first, do you remember how to graph that equation? It's what we've been spending a lot of time on in the last several weeks. So I see that it's an x squared graph, so I know it's going to start with my x squared points. You don't have to write these down on a normal problem, but just as a refresher. And then this -1, hopefully you remember from like everything we've been doing, that's going to take those points down 1. So I'm going to plot those points. And then, just like we've always been doing, I'm going to shift them down 1. Get rid of the old guys. Now, I'm not going to connect those dots because I'm not sure where that curve is going to intersect with the line. So I'm going to wait to connect those dots. So it's been a long time since we've graphed a line. Hopefully you remember y equals mx plus b. The slope is 1, the y-intercept is 1, mx plus b. So I start at 1 on the y-axis, and then I go up 1 over 1 and down 1 over 1. I can see right there that pink dot is overlapping that blue dot. So I can see that that line is going to cross the parabola, the curve, right at that point. So I didn't connect it on the right for a reason I'll tell you in a minute. But I can see that this point right here is a solution, and that point is -1, 0. So that's one of the solutions, okay? Now, if I just randomly draw a curve and randomly draw a line, I'm probably not going to get an accurate number for where they're clearly going to intersect over on that side, but I'm probably not going to get an accurate value. So I want to keep going with the slope. Just to be cautious, I'm going to go really far. So I know that's going to happen, okay? So now, I know what this graph does all over here. I'm good with, they're not going to cross again, so I'm good with just randomly drawing it this way. I don't need another point over there, but I need to know what happens over here. I do not know what happens right here at x equals 2 on this curve, okay? I've got points all over here. I've got a point for a 0. I've got a point for 1. I've got everything I need over there. So I want to know what happens when x equals 2 on the curve. So I'm going to take this equation, y equals x squared minus 1, and I'm going to plug in a 2 to figure out what the y is. And I see that the y is 3. So I'm going to go over 2 and up 3. Lo and behold, that's the same point as the line. So I can see that that is also a solution because they intersect there, that point 2, 3. So 2, 3 is the other solution. So that's the answer to part A. And then part B wants me to, let's see, probably not going to have any space. Part B wants me to verify my solution. So as I mentioned at the very top, I'm going to plug in the solutions. So I'm going to start with -1, 0, and plug into the first equation. And I need to remember that -1, if I'm squaring the whole thing, becomes +1. That is a true statement. And then I want to plug also into the second equation. Oops. Y equals 0, x equals -1. That is also a true statement. I'm totally not going to have space for this. There's more space on the homework page for you. Actually, let's move over here. Still part B. I'm going to take the other solution, the 2, 3. I'm going to plug into the top equation. So y and then the x, and that is a true statement. And then plug into the bottom equation. So the y goes in, the x goes in, and that is also a true statement. So verify just means plug in what you got as the intersection points into both of the equations. So you're plugging in 4 times, 2 for each point. Okay, so I'm gonna have to do this one a little bit quickly because I got a standard 10 minutes. All right, so hopefully you remember that when there's a number in front, that means you multiply the y values of your points. So start with your regular y equals x squared points, because this is a y equals x squared equation, right? X squared. Multiply the y values by 2. The x values stay the same. So those are your points that you're going to start with. And then you're going to shift them left 1 and up 2. So left 1 and up 2, get rid of that guy. Left 1 and up 2, oops, that's that guy again. left 1 and up 2. So there's my parabola points, and just like I did before, I'm not going to connect the dots yet. This one, slope is 2, y-intercept is 4, y equals mx plus b. So I'm going to start at 4, and I'm going to go up 2 over 1, down 2 over 1. Well, look at that. I just connected at 2 places right there. I started at 4, I went down 2 over 1. Those were 2 blue points right there. So if you draw it very carefully, you'll see the parabola is a curve. It's actually going to curve like that. And so you already have, you don't have to do any extra work like the first one. So you already have those 2 points. This is -1, 2. And this is what? 0, 4. So those are your 2 solutions. So instead of, I only have, oh, I think I'm going over. Hopefully YouTube will let me load it. I can't remember if it's 10 minutes or 15 minutes. Okay, so I don't want to spend more time just in case I have to cut this. So I'm going to trust that you guys can plug those in. You're going to plug them into the first equation. Let me do one into the first equation because that's kind of funky. So part B, 2x plus 1 squared. So I'm going to plug in the -1, 2. So I'm putting the 2 in for the y. And then you just have to PEMDAS that. Parentheses first. Exponents. Multiplication. You're probably not going to show that many steps when you do this, but that's true. 2 does equal 0 plus 2. So then you would take this -1, 2 and plug it into the bottom equation. Then you would take the 0, 4 and plug it into both of the equations. I do want to say one thing really quickly though. This problem over here where we had to find the extra point, where we were plugging in another number, for some reason people always skip that. It's in your homework tonight. You need to know how to do that. I'm going to tell you right now. You have to know how to do it. It's on the test, okay? So some of them will work out nicely where you already have your points and you just have those 3 parabola points. Other ones, the 3 parabola points were here. We need to go over and figure out another point. So count it out. This is x equals 1, x equals 2. We want to know what happens when x equals 2, so we plugged in a 2. Okay, so I hope you did well on your quiz, and I will see you guys. Have a good 3-day weekend. I will see you on Monday. Make sure you finish the graphs on the front page. You read the stuff directly above these examples, and then you work the 4 problems on the last page.